Thank you for joining us for today's conversations, Art, Science, and Wonder in the Medieval World. I am Greg Sandoval of Getty Museum Public Programs. Today's two discussions complement the magnificent exhibition, Lumen, The Art of Science and Light, which is currently on view at the Getty Center through December 8th. It is a marvelous exhibition, so if you're on site today, definitely make some time to see the exhibition. It is only up for 4 more weeks, so if you think you're coming back around the holidays, it may not be up again. For guests here in the auditorium, I just want to remind you to please silence your mobile devices. And for online attendees, we've enabled closed captioning. To access live captioning, please click the CC button icon on the Zoom menu bar at the bottom of the screen. And then following today's conversation, there will be time for questions from both in-person and online. For the online audiences, please use the Q&A function on the Zoom to submit your questions. And here in the auditorium, we will have mics that will be brought down that you should use to ask your questions. We want to make sure that everyone in the auditorium and online can hear your question. Now I would like to turn the program over to Getty curator Kristen Collins to introduce the first panel and the exhibition, introduce the exhibition and our first panel, What Was Medieval Science? Thank you.
Good morning, everyone. Thank you so much for joining us here today, and a special thanks go out to Greg Sandoval, Daniela Alvarez, and Danielle Espino for their help in organizing this program, as well as to my two co-curators, Nancy Turner and Glenn Phillips, for their collaboration on the exhibition that inspired this event. As Greg mentioned, the exhibition is part of the Getty Foundation's PST Art Initiative, a landmark regional event that explores the intersections of art and science. And we are hugely, hugely grateful for all of the inspiration and the educational opportunities that this theme has provided. Adding to your information about our program, I do want to mention that we hope that those of you who are still with us at the end of the day after the second section will end the day with us up in the galleries for a multi-sensory activity. And I will say no more about it, but it will take place in front of some truly spectacular objects and I think be a very special way to end the day. The Lumen exhibition uses the theme of light to explore the overlapping histories of science, religion, and art during the long Middle Ages, from about 800 to 1600. Lumen presents a story of Europe in conversation with a larger world through the shared language of science as medieval people engaged in the common pursuit to better understand the workings of the cosmos and the mechanics of vision. We are very lucky to be able to bring together on stage so many of the people who have just been essential members of the exhibition team and who have contributed to it in so many ways through advice given and the scholarship that has inspired us. Moderating both of our panels is Barry Smith, Professor of Philosophy and Director of the Institute of Philosophy at the University of London's School of Advanced Study. All right, yes. As the founding director of the Center for the Study of the Senses, which promotes collaborative research opportunities between philosophers, psychologists, and neuroscientists, he is the perfect interlocutor for today's wide-ranging discussion on the intersections between medieval art and science. And without further ado, I leave the stage to our esteemed panelists.
Hello and welcome to all of you here, as well as those joining us online for this session on the art and science of light to accompany the Lumen exhibition. Thank you to Kristen and to Greg and to all of those who've made this occasion and also made the exhibition possible. We're going to start today by focusing in this session on what we mean by, what was medieval science. And with me to discuss this, I've got a very eminent panel. So immediately on my right, your left, we have Megan McNamee, who's a lecturer in the history of art at the University of Edinburgh, where she teaches on the interplay between the art and science in postmodern Europe. She was a Getty Fellow in residence here during the lead up to this exhibition and the planning of it, and served as a member of the Lumen Scientific Committee. Immediately on, thank you. Immediately on my left, your right, we have Margaret Gaida, who's a historian of philosophy specializing in medieval science, and she is at Caltech in the Division of Humanities and Social Science. She was also working as a researcher on the dissemination of Arabic numerals and natural philosophy in Europe, and served as a guide in the planning stages of this exhibition. So another person who's been deeply important to the delivery of the exhibition as we know it, and another member of the Lumen Scientific Committee. Finally, we have Ladan Akbarmia, who is a curator of South Asian and Islamic art at the San Diego Museum of Art, where she has just launched an extraordinary PST art exhibition titled Wonders in Creation, Art, Science, and the Innovation of the Islamic World. The exhibition explores art and science through the lens of wonder and is on display until January the 5th. So another very important person to have on this panel this morning. Welcome all our speakers, please. So when we think of medieval science, we have to do something of a mind shift from the conceptions that we have nowadays about the relations between science and religion. They were not always so far removed. There was, in fact, something that corresponded more to an alignment or a coincidence of aims and ambitions. And I think we have to remember as we explore this topic how breathtakingly ambitious a lot of medieval science, medieval thinking was. The desire often was to try to uncover, reveal, explore an ordered universe, and science was a way or a method of trying to get at something which revealed maybe the divine plan of God. Now, when you think of it that way, you maybe come to see that science and the pursuit of science was equally possible for someone who was a theologian, and many of the leading scientists were also theologians. But also we have to realize that the views that contributed to the medieval conception of the world were radically different in many ways to the ways that modern science would think of the world now. And I think since we're dealing with an exhibition on light, perhaps it's striking to remember that it was quite late in our history in which we began to think of the rest of space as dark. In fact, it was considered to be filled with light. The blue sky and the way we looked up to the heavens in daylight was thought to extend throughout the cosmos. What we called darkness was in fact the Earth's shadow casting us into darkness, taking the sun away from the illumination. So very different but intriguing ways of thinking. So when we try to approach medieval science, we have to get underneath our ordinary conceptions of science and try to inhabit the medieval world in which not only was science exploring the world, but it was also exploring our place in it. And we, as individuals in medieval thinking, were often, although individual, reflections, mirrors of that ordered universe. So Aristotle thought that there were 7 planets, 7 celestial spheres, and that was mirrored by the 7 orifices in the human face. Okay? So there was a way in which we were embodying or showing our relationship to the rest of the universe. So there was a tremendous amount of connected uniformity of thinking, but how it was pursued, how it was developed, what was coming through the ambitions of the theologians and scientists working, and how they both informed artists and artists helped to reveal something of that thought to us. That's what we're here to explore with our panel. So I'm going to turn first to Megan, and the question, the exam question, as it were, for all of the panelists, which was really how should we think about the object and the practices of medieval science? What were they trying to reveal and uncover, and what were the ways and methods of doing that? So, Megan, if you would start us off, please.
I feel like this should be like a buzzer where I can buzz in with the right answer. Thank you so much, Barry, for that kind introduction. And there is our question, and there's my name. And here are the two things I would like that come to mind when thinking about medieval science. So this term science that we use today has its roots in the Latin term scientia, and that means knowledge generally, but often defined a particular kind of knowledge that was a truth, a perfect truth, indisputable, unchanging, etc. And in the Middle Ages, it was thought that you could find that kind of truth, both in like the Bible, because it's divine, it's ultimately divine, but also in creation, because creation was understood to have been created by God, and so it too was a divine entity and reflected God's divinity. And they thought that the way that God made the world was based on number as arithmetic, number as geometry, etc. And so the two things that I'd like you to come away with today are that throughout the Middle Ages, number was understood to be the basis of matter, somewhat almost like an atom, so almost an atomic notion of number. And then that the eyes were known to be the nexus of numeric discovery. And I'm going to help you understand what that might mean with the help of this astonishing work that's held here at the Getty that I don't think it is in the show, the Sondheim Missal, but in this frontispiece, so full-page illumination showing God creating the world. Each of those circles represents one of the days of creation as recounted in the Bible and the process of creation. And when in the Bible it's summed up that God made the world by number, measure, and weight. And I think you can see that orderliness that Barry was referring to, even in this image. So it is a geometric process informed where everything is parsed equally, it's balanced, it's highly, highly rational. It's centered on a perfect point. It's a circle which was understood to be a kind of perfect form. And so I think that this image really reflects that notion of the rationality of divine creation. But that extended not only to the moment of creation, but then to all created order. So you could recuperate this rationale, this divine rationale that was numerical, that was understood to be numerical. It was understood to be arithmetical and musical and astronomical and geometrical, could be recuperated through observation, through the study of the whole created universe. And I think that comes across really well in this quote from Augustine of Hippo, so a father of the church living in the 5th century. And he writes, "Look upon the heavens, the earth, and the sea, and at everything in them, whether they shine down or creep below or fly or swim, they have form because they have numbers." And then he goes on to say, "Craftsmen who fashion bodily forms have numbers in their craft, which they apply to their works. And if you expect the beauty of those sculpted forms, you see numbers held in place." And so what you're seeing here is a very literal understanding that in what is underlying the order, the very geometry of our forms, of our world, is numerical, and that those numbers themselves are divine, and understanding them is a divine pursuit. And even when we make things, so craftsmen, sculptors, architects, painters, anytime they make something, that too is full of numbers, because they are creating in the mode of the creator, just as God did. They are creating things in that same fashion. And so in terms of medieval science, we today understood that a lot of science is expressing some sort of truth, and it is pursuing an understanding of nature. And so we see very much a resonance between what we think of now, and in fact, we often think that you can verify or quantify science through numbers, through mathematics, is still fundamental as the process of science. And in the past, though that mathematics was quite different, though the understanding of number was different, it was still understood to be quite significant and important for understanding the world. And here you can see a close-up of what we were looking at. And finally, before I pass it on to my colleagues, I just wanted to bring this quote from Plato. And so we might think that Plato, he's Greek, he came before the Middle Ages, they wouldn't be interested in Plato. No, they were quite interested in Plato. And in fact, Plato, his work called the Timaeus, was read alongside the Bible and was thought of as a secondary, a sort of scientific account that expanded the account of creation that they found in the Bible. And it's really quite extraordinary, because Plato, in the Timaeus, he talks about the creation of the world, and then he talks about the creation of man. And what is created first is man's head, and his head is created as an orb, which again, this perfect spherical form that looked like the bodies in the heavens, so the planets and the sun and the moon. And so humans too were made in this perfect spherical form, and then they were given perfect spherical eyes, and the sort of, those eyes were given a job. And so Plato actually says that the greatest benefit of sight, of eyes, is our ability to observe the world, to see the periods of day and night, months and years, ideas of times that open the path of inquiry. So by observing the world, they open the path of inquiry and allow you to discover numbers. So again, we're seeing exactly what Augustine was saying and what Plato's saying. And they've given us the idea of time and opened the path of inquiry into the nature of the world and even philosophy. So actually, through the observation of the heavenly spheres, through vision, we then come to all knowledge of the world. So I think this is very much a scientific perspective that we recognize today in the past.
Thank you very much. So I hear in what you're saying, Megan, that the perfect order of the universe is going to be sort of enshrined in number, or number is going to be the skeletal code to that order. And insofar as the medieval thinkers were taking their lead from Plato, they're thinking of the numbers as Platonic, as existing eternally, unchangingly, abstract, not part of the physical or natural world. So I wonder if that leaves us thinking that we're dealing mainly with reason as a way of unlocking the order, and then laterally you mentioned observation. So I want to take your lead of moving to observation and not just reason, to move now to Margaret Guida to talk about how we might add to that method of science, not just the numerical, but maybe the experiential as well.
Thank you so much, Barry. And thank you, Megan, for that wonderful introduction to the topic. I'd actually like to pick up right with Plato, because he's one of the earliest thinkers to have a scientific theory of vision. One takeaway for Plato's theory of vision is you can think of it as laser beam eyes. So he had an extramissionist account where visual rays were actually emitted from our eyes, and that's how we could grasp or see an object, was through this extramissionist account. There were also several other Greek thinkers. Some of you may have heard of Aristotle, who also had optical theories, as well as Claudius Ptolemy in 2nd century CE, and of course Euclid, the geometer. So the Greek tradition really formed an important basis for medieval optics, and particularly because many of those Greek texts were translated into Arabic and taken up by Arabic scholars in the 8th and 9th centuries. And that's really where there's this incredible flourishing of the Islamic Golden Age. Hopefully Ladan will also speak a bit about that. But the works were synthesized by a scholar named Ibn al-Haytham in the 11th century in Baghdad. And Ibn al-Haytham wrote this masterful work on optics, where he was able to synthesize many of the Greek theories as well as some of his Islamic predecessors. And what's important about Ibn al-Haytham is that, in one sense, it's true that there is this sense of desiring to study the ordered universe of the divine. But Ibn al-Haytham doesn't mention the divine at all in his treatise on optics, except for his traditional invocation at the beginning of the text. And his work has been recognized really too as illustrating some of the earliest scientific experimentation on optics, as well as treating some of the Greek topics in a new way. So reflection and refraction as well are treated in a mathematical way in Ibn al-Haytham's work. So he really was a turning point in terms of understanding the history of optics before this sort of mathematical, in the sense of diagrams, the treatment of light as a ray moving in a straight line, and those sorts of topics before the 12th and 13th centuries, when those ideas entered Europe as a result of translations from Arabic into Latin. So it's a really rough chronology of a very, very complex overview, but the idea that I'd like for you to sort of grasp is that Ibn al-Haytham's work really set the stage for the study of optics in Europe in this sort of experimental and mathematical way. And so when you think about, for example, the way that you might imagine light filtering through pine trees on a foggy morning. If you've seen that before, you can see very clearly that the light's moving along straight lines and rays. And so this effort and desire to then study that and look at that phenomena in a dark room through an aperture, or eventually through a lens, right? Studying and understanding that phenomena then became this sort of project of the perspectivists in Europe. So those are figures like Roger Bacon and John Petcham, who were also inheritors of this incredible Platonic tradition that Megan has mentioned, but then also had studied Ibn al-Haytham and, of course, the works of Aristotle. And what makes them interesting, I think, as well, is that they then really married these two traditions. And so in the work of Roger Bacon, taking inspiration from his theories of light and vision of Ibn al-Haytham and then drawing on his own predecessors, he then came up with this really fascinating concept, which he called the multiplication of species. The multiplication of species explained celestial influence on the Earth because of the light being emanated from the sun and then reflected on the moon. It explained the astrological influence of the planets, which of course was commonly held notion at the time. And it also explained things like the power of prayer. So when you say a prayer, the words coming out of your mouth actually hold these sort of different powers that then will impact whatever it is you're praying for or praying about. And that was all sort of from his study of light, right? That where all of this originated. I think that in looking at some of these diagrams, which you can see as well, The study of the light rays entering the eye was also well documented. What happened when light actually entered the eye, it needed to enter perpendicularly, otherwise there would be sort of visual confusion. And so authors were concerned with that. In this diagram as well, to connect to the Christian tradition in Europe, one of my favorite aspects of some of the text that we're looking at is the looker, right? You can see on the far left of the diagram peeking in to see this vision of the Lamb. But this idea of the metaphor of a vision also for the divine, which Megan discussed, was then integrated with this more mathematical, diagrammatic tradition that came from Greek sources into Arabic and then into Latin. As well as study of the rainbow. And so you can see here this sort of very specific diagram on the left, right, with the light moving along straight lines, refracting against water droplets, right, and then producing a beautiful vision of the rainbow that we see in the heavens. So I think oftentimes we as modern thinkers didn't realize how knowledgeable medieval scholars actually were and how detailed their studies were in being able to describe and explain different natural phenomena. And you can see all of these examples in the exhibit. Lastly, I just wanted to draw your attention to the playfulness as well of medieval scholars. And so as another example of their ingenuity, you can see instruments such as the astrolabe and quadrant, which scholars use to calculate the time, to calculate positions of the planets in the sky, and also to measure the height of buildings, or in this case, you can see the goat measuring the height of the letter in Ptolemy's great work on the Almagest, which is a treatise on predicting planetary positions and mathematical models for celestial motion. And so, again, the takeaway there is the bringing in this idea that medieval scholars were very creative. They were engaging very deeply with mathematics. They were really drawing on centuries of traditions to synthesize and then come up with their own ideas about different phenomena in the natural world.
Thank you very much. That was a great prospectus, and as you said, you even got in the transmission of knowledge, having come from Arabic scholars translating from the Greek, the ancient works of Plato and Aristotle, and then they were subsequently translated in Latin, and then we had the spread and transmission of ideas. But I think the key thing that you help us see here is the inclusion through Aristotle and through somebody doing real scientific work like Al-Hazan, just thinking that they're trying to experiment and demonstrate and confirm for themselves what they should think about the phenomena of light. And of course, if you're studying light, you're having to study us, who are the receivers of light through the eye, and you're studying optics. And if you don't understand that, then your view about the universe got through astronomy and looking at the heavens isn't going to be right. But you mentioned rather beautifully that they were creative. And I think it's worth reflecting when you see treatises on, say, the rainbow, and you gave us one here, and of course, Robert Grosseteste also writing about it. You think, is this just a frivolous exercise? Well, no. I mean, even today, psychologists and neuroscientists still ask the question, why do we see different colors in the rainbow? After all, light is a continuous spectrum, so why do we see stripes? And we still don't have an answer to that. So they were fascinated by things that continue to fascinate us. But finally, and as a bridge to Ladan's presentation, you mentioned having to use instruments and fashion things like astrolabes, which you can see in the exhibition, to try to unite our experience, our own understanding of that universe with the calculations that led to the precise construction of the astrotype. So there's a role for craft here as well, I think. And Ladan, I wonder if you would take this on and also tell us a little bit about the different religious traditions and how they were conceiving of medieval science.
Thank you. It's actually a very nice segue. I will not be talking so much about the translation movement that you mentioned, but it's very helpful that you did, because I am looking at this through the point of view of a cosmography. Let me just see, which one is the
green one?
Green one. That's okay. And there I am. Okay. I'll also start with a couple of quotes that date to the medieval period. This particular one follows nicely after your mentioning Ptolemy and the Almagest, or the Almagest, because this celestial globe that was dates to about 1288 and can be connected to an observatory in northwest Iran in the city of Maraghe, was made by an astronomer whose father was in the service of Nasruddin Tusi, a very well-known, celebrated astronomer who worked in the service of one of the Mongol Ilkhanid rulers. And it's based on the treatise and the studies of a Muslim astronomer named Al-Sufi. And what he did was he took Ptolemy's Almagest and he compared the over 1,000 stars and constellations to those that Ptolemy had shown, and identified, compared them to the Arabic ones, and then created a treatise that really shows you both how we see these constellations from our view here on Earth, and also from what they look like from above. So the celestial globe will show you what they look like from outside of the Earth, and this is what this instrument is showing you. So I'm just going to read this quote because I thought it was a nice way to kind of lead us into the view during this period. Intellects are I can't read this very well, so I have to do this. Intellects are in agreement and minds are in accord as to the excellence of science and the worthiness of scientists. Through science, happiness is obtained and ranks are elevated. It sharpens the intellect and strengthens it. It increases sagacity and augments perspicuity. It is by it that the indolent is embellished and the obscure is rendered illustrious. By the way, imagine this written in the original language, Persian, even Arabic. It's always very, very flowery. And it is with its help that the true is distinguished from the false. All this is especially true for those sciences whose object of investigation is demonstrative and whose principles are indisputable and self-evident. Indeed, this kind of science is common to people of different religions and does not show variation with the passage of time or change of location. So this is Shamsuddin Muhammad ibn Muayyad al-Ordi, and it's lovely that we actually have an instrument that is connected to him, which you can see if you come to the exhibition in San Diego. And I wanted to take that idea of science as not only this effort to investigate and learn about what is factual, but it's actually a part of one's refinement and of strengthening yourself, and it also brings you closer to God, which is exactly what, sorry, I'm going to skip through this. These are just examples of Al-Sufi's treatise, copied in later years or based on this idea of these mirroring constellations. Sometimes they're back-to-back, sometimes they're facing. So Ghazvini, Zakaria bin Muhammad al-Ghazvini was an Islamic scholar and judge who lived in the 13th century. He was born in 1202 or 1203, and he survived 2 Mongol invasions. He lived in northwest Iran in the city of Qazvin. He came from a family of Arab immigrants. And during the first wave, he moved to closer to Wasit and Baghdad in Iraq. And that's where he wrote this cosmography after the second wave of invasions, which really basically wiped out the Abbasid Caliphate in 1258. But he, at this time, had been schooled in the Islamic madrasa, and he really represented what a learned scholar of his time would know. And in this time of chaos and tumult, it's as though, in 800 years ago, or over 800 years ago, he wanted to capture the entire world in a book. And that book was a cosmography, which is distinguished from an encyclopedia or a natural history in that it not only brings you facts in these entries, but it gives you also popular tradition. So it has this combination of types of knowledge. And all of these kind of fit under this idea of ilm, or which is the Arabic word for science, but also in general, this sort of all-encompassing knowledge. So Ghazvini says about this, why he wrote the book. He talks about his having to be displaced, and then he wanted to write all the knowledge that he had, including what was translated. You know, he cites Ptolemy, Aristotle, Ibn al-Haytham, but also Indic oral traditions, other texts. And then he says that I wanted to write this so that I could preserve what I know into a book. And then he talks about how I devoted myself to contemplating the wonders and marvels of God's creation because God, and he quotes the Quran, has said, "Do they not look up to the heaven above them and consider how we have raised it and adorned it," sorry about the typo, "and that there are no flaws therein." So at the very beginning, everything is happening because our job is to contemplate God's creation, divine creation. And so this is not very dissimilar to what we've heard. And so then he talks about looking. What is looking? And so I thought it was really interesting that you talked about looking, Megan, and the idea of the senses that we, whether it's from Plato or that sight plays such an important role. Ghazvini calls upon us in the very beginning of his book to actually approach the world and seeking knowledge through this idea of wonder, which is that feeling of perplexity we feel when we don't understand the cause or the impact of something. And to do that, he wants you to use all your senses. But by looking, he says, what is meant by looking is contemplation of the intelligibles, those things we understand, investigation of tangibles, and uncovering the wisdom in them to reveal their realities, for that is the cause for worldly pleasures and otherworldly felicity. Regardless of whether something is concrete or abstract, it's in that process of contemplation that we pursue that path of discovery, and there are rewards in that because it'll bring us closer to God. And so the contemplations of intelligibles only comes to somebody, and I thought this brings us to the mathematics, it only comes to someone who has acquired expertise in the mathematical branches of learning after improving his character and refining himself. At that point, the eye of insight is opened, and one can see in everything something wondrous that cannot be mentioned in part, because if only a part of it is mentioned to someone else, he will deny it. And so this is the kind of perspective that we take, looking at medieval science through Ghazvini's eyes. And so just as an exercise, a later copy of his work was written in the 13th century, he died in 1283. This is a copy of opening pages to his book, which brings a quote by someone else who's kind of capturing the entire structure of his book, which is a description of the entire universe, the cosmos, from the heavens to the earth, all the orbs and spheres in between. But to do that, he covers everything from geography, the animal, all the kingdoms, before that, all the parts of the heavens, the habitats of the angels, the habitats of others. And when he gets to the earthly realm, he talks about habitats and the properties that are somehow related to our living and what we can make of those. And included in that is also the idea of alchemy, the transformation of matter. So I'm showing you this work to just say that not only do these opening pages use a quote by another poet who actually pre-existed him, to say that this is about this, he says, foremost of all generated beings are intellect, foremost of all generated beings are intellect and soul. So before we can even exist, we need that intellect or reason. Then come the heavens, then come the earth. And the actual, I can't zoom in on this, but all of the elements you see are reflecting an image, the entire cosmos, from what the creatures you see in them, the animals, and then the quote itself does the same. And the process of doing it is also using that science by the way that, the gold pigment that's used, the lapis colors. So all of these are also brought into it, as does a commission for the exhibition that I've done in San Diego, where this artist, Have Kahraman, who's based in Los Angeles, she's a Kurdish Iraqi artist who immigrated to Sweden. She's a refugee. And she was really fascinated by a certain part of this text, which I won't go into, but in her process, she also uses she touches on these various topics, including showing a palm tree, But for her, the palm also has this connection to grief, or these bulbs that you see for the legs of this sort of composite creature that are tied to the mourning flower, or the gole ghamgin, that for her it's a Kurdish flower that reminds her of grief and really processing her own experience, and to the celestial, the snake, that is drawn from also the celestial realm in some of the works in the show, but also the shedding of skin, to the actual substrate she prepares, which is flax fibers that are woven, and then and the marbling of the surface as well. And so, and it also actually relates to some of the crafts that Ghazvini talks about in a Persian version. There's a very special Persian edition. He writes this text simultaneously in Persian and Arabic during his lifetime. And the Persian edition is distinct because it has a section that kind of expands on the animal kingdom, the section on human beings. And he lists these 20 crafts or skills of human beings. And this is where craft really comes in, because he talks about several different kinds. I mean, carpentry is one. And within carpentry, you actually, weaving is one, which is why I brought it back to this. But in carpentry, he talks about the building of a water wheel, or the building, the making of different automata, and he actually goes through these descriptions. And these also show that he was aware of other writers who'd been writing about mechanical devices, like Al-Jazari. So the images on the right and left show you, on the left, automata. The image on the left side of this page is also showing an automaton in his Persian edition of his book. It's a later copy. And to the right, another example of a water wheel. And this is just to show that throughout the book, he's drawing upon texts constantly that ground what he says in what he's read and the sources that he has that are by established and respected scientists of his time. But also, it brings up this other idea of this book and the way that it was illustrated over time as a way of actually bringing out in the way that the object is delivered. So this object, as whether you want to look at it as a work of art or a work of craft, he wants you to take time and concentrate and investigate things. And by doing this, the more image also played into that, into your experience, your eyes also linger longer on the page. You want to understand what it is that you're seeing and try, and so the way that you look at something, the way that it was delivered is as important as the way that, as the content that it's carrying. So to just, the last thing I just want to point out is how this also comes out in other works that we look at, and how I just wanted to maybe put a question out there also about the idea of where craft fits into science, and whether it always has to be something that is established or proven, or whether it's an actual transformation of matter in one sense, or whether it's also the intellect of the artist's hands, as Margaret Graves has put it, and what role artists, craftspeople, many of whom, astrolabe makers, many of whom were also, oops, what did I do? Pressed the wrong thing. Okay, many of whom were also poets or courtiers or polymaths. Just to show you a very well-known astronomer from Iran, Al-Yazdi, who was known for making these instruments. And finally, today, a contemporary artist who's taken all of these philosophers and brought them together in this sort of composite image of the sun that was taken in March, superimposed over all these texts. And so I think I'll leave it there and see where you want to take it from here.
Thank you very much. Thank you. So that was a fantastically helpful way to bring in the idea that not just mathematics, which is there, immutable, unchanging, beyond the natural world and somehow in a Platonic realm, not only that was a common currency, but science itself, as it was practiced, was a common currency across these different religious traditions. So we've got Christian, Jewish, Islamic scholars all able to think of developing, contributing to the layers of science, drawing on the works of the ancient Greeks that were translated and that were coming into existence. And you brought out beautifully the way they're dealing with both the ambition, that wonderful idea of almost having a theory of everything. I'm going to write in a single book how everything fits together, and it will reveal the divine order, but it will show how things work. At the same time, has to be rooted in experience. We need to talk, as you said, about our senses, and when you bring in the senses as also part of receiving that understanding, there's a hierarchy of the senses, and definitely vision is at the top, is absolutely at the top. Light, revelation, we talk about assembling observations, we talk about seeing things in order to understand them. But I'm wondering whether, when we talk about that, we need to have the action part of it, not just the passive part of it, not just our senses being bombarded. And you brought out, I thought rather beautifully, the idea of practice and action and making, which are important, because people forget, even nowadays, that there's a practice in science. In fact, there's established just recently a Centre for the Study of Practice in Science at Imperial College London, where Roger Kneebone, who's a surgeon, great name for a surgeon, but he's interested in the fact that some scientists are better experimenters than others. And is that to do with the way they handle the beakers, the way they move things, the way they put the materials together? And everybody knows in the lab who's the really good experimenter. So it's as if practice is something that has to be inculcated also, has to be taught. There's a craft to learning to be a good scientist, perhaps.
And that there's knowledge that actually comes in the process of craft, in the process of practice, that isn't something that can necessarily come in the process of reading.
Right. And I wanted to come back to you, Megan, on that point to say, you beautifully laid out the discerning of the sort of numerical structure that existed in the ordered universe, but where does experience lie in this?
Yeah, I just wanted to pick up on what you were saying about the way you almost calibrate the eye through practice and through repetition of different actions, and through observation. It was very interesting that they bring up that it needs to be trained, and that training brings a delight, a sort of joy to it, and a dignity to it. And so science is a process that one learns, even in this earlier period. But also, even going back to Plato, that one observes the heavens and one discovers numbers, but there's an effect that observation has on the body and the soul. And this is picked up by Christian authors later, and is continuously referenced throughout that the effect of observation is something that's experienced both spiritually and so mentally through sharpening one's acuity, but also very much through is in the body. And so when you look at the quote from Augustine that I brought, where it's just like, look at the gestures of the craftsman. We know craftsmen were learned by endless practice. You worked under a craftsman and learned the art very slowly through imitation, through practice, through repetition, through drawing the drawings that were owned by the workshop, and doing that over and over and over. And so I do think that this idea that observation and action and transformation of the body are very much linked in all of these practices, both the artistic and the scientific, in this earlier period. And now I've blanked on the question.
No, you did that beautifully, and I want to sort of riff off that, if I may, because that thought about learning one's craft, which we talk about, which is both in the arts and in crafts, but also in science. But as you train and discern and get better at making and doing, you get better at seeing and appreciating what's there. It's almost as if the art of making something helps you to discern what it was that was made. But I want to come back to, as you said, the effect on us, the reception on us of light and of the observations we're having, and come back to this tantalizing thing you said, Margaret, about our words changing and having impact on things. And I'm really keen to know more about where that comes from. I mean, if we have the hierarchy of the senses, we've got sight, but then we have hearing, because hearing's hearing the word of God, and also because this wonderful thing that Aristotle said, the sound of a voice is the sound of a human soul. So it's quite potent when words strike us. They're putting us directly in touch with another being. But how do words, as it were, change things? And can you say a little bit more about that? Because I was really intrigued by it.
I can say a little bit more about that in particular, and then hopefully connect it out to this sort of broader question of influence. Yeah. So it's from Roger Bacon's work on the multiplication of species. And so his idea was that objects at all times are emitting what he calls species, which are basically little packets. If you can think about light, in our modern understanding of light moving as a ray, but then also being composed of photons, right? A species would be like a medieval photon, if we can compare it in that way, right? And objects are emitting them at all directions at all times, right?
I think of Reese's species.
Okay.
Like little tiny things coming
little
at you.
Packets of but they contain the essence, right, of the object that's emitting it, right? And so it was not a difficult leap intellectually for people, because their worldview was so vastly different from our own, right? They were in a completely interconnected cosmos where it was very obvious that there were planetary effects on Earth, because they observed the seasons, they observed the moon's influence on the tides, and so planetary influence was just a step beyond that. And so this sort of observation of interconnectedness, and then making an effort to explain that in a way that combined reason and experience, right? And so Roger Bacon making the connection that, we see light moving in this way, and so maybe we can explain celestial influence in this way, and so then maybe we can explain prayer in this way, was the next logical step. That's also not outside the realm of things like magic and incantations. And we're focusing on medieval science, but again, along with all of this sort of diagrams and schema and things that sort of resemble science more to us during this time period, there were also sort of phenomena or things that people were practicing, like spells and incantations, that then scholars would try to understand, what was really going on behind them. They tried to explain it in a natural way. And so that's something too where, from our modern perspective, when we think about magic as being something that's unnatural or supernatural, right? During the medieval period, there were real efforts to explain, for example, the transmutation of matter in alchemy. That's a natural process. It's alchemists in the laboratory are just mimicking and practicing the same sorts of activities that happen naturally under the earth. Similarly, with astrology too, there's this understanding that the planets are sort of emanating rays down. They may not, that's light or heat, right? But there's something physical, natural that's happening that's then impacting both individuals, the weather, earthquakes, plague, right, diseases, right, all sorts of things on Earth, as well as the lives of individuals.
And I was going to ask you about the point you made about wonder in here too, because sometimes people talk about that a little bit dismissively, because they'll say, if we got the science of something, that we're trying to understand about empathy or whatever, it would take all the magic out of it, they say. It would take all the, if we understand how human beings work, it takes the magic out. But the thought you were hinting at was, no, it wouldn't. There's a contemplation and a pleasure from understanding which unites art and science, the getting something, the quietly contemplating and taking it in and letting it dwell with you. And a lot of scientists will say that, if I had an explanation of some of these mysterious phenomena, it would add to the wonder rather than take it away.
Absolutely, and I think you first really brought together well this how do we factor magic into it, and spells and all these things. And because for me, all roads lead to Qazvini, who wrote the cosmography I talked at length about. this is all included there as well. And I have people who come through the show and say, well, how could that be? You know, he's Muslim, this doesn't work. Well, for him, and this comes back to wonder too, but everything on Earth too, when the things that we can't explain ultimately also have to do with harnessing celestial forces, harnessing the unseen to produce wondrous effects on Earth where we can see them. So no matter what, everything is ultimately explained, you know, by divine creation. But wonder, whereas it may be something that we think of as what we don't understand or what's scary or fantastical and has no explanation, for Ghazvini, wonder could be something like that. And he calls these rarities. Rarities are types of wonders, like a comet, or something that's rarely seen, like, you know, a creature, a hybrid type of creature that we wouldn't say exists right now. But it's also the fact, the very perfect hexagonal honeycomb structure of a bee, that a bee makes, that a bee creates, or the way that a tree, he writes at length about how water nourishes a tree, goes from the roots into the trunk, goes up to the trunk, to the branches, to the stems, to the leaves, and that these leaves give you shade when it's hot, and they give you beauty when they fall. And isn't that amazing? Isn't that amazing what God's creation gives us? But only by thinking about that, because usually we might just look at it and not think twice about it. It's only in that process that we understand more, and that's where the wisdom comes in. And you can do that with anything, and you'll never stop, because there'll always be something more. And so I think the artists, also the contemporary artists that were brought in, but really start with a question. The question leads to trying to discover something, leads to challenges, and then ultimately comes to the product. And then our job begins where that stops, where we engage it, and we engage it in different ways.
Oh, and this was your question that you just
Yes.
that I forgot. But the idea that you have experience and observation is sort of baked into that. We watch the natural world, and this is really baked into most accounts that are trying to explain divine order, even before a period where we think that there are formal, systematic experiments being conducted as such. It is, throughout the Middle Ages, really key that one make a statement and then defend that statement, perhaps by referring to an authority who's written about it before and can verify, yes, a water droplet forms in this way for this reason. But then also by referring to the experience of the reader or the beholder, if there's an image involved, that it's like, this is like this thing you've seen, or something that you've experienced. So that experiential, observational quality that we associate as absolutely essential to scientific pursuits was, in fact, within the realm of medieval science as well, throughout the period that we're at least talking about.
And it's that sense of recognition, as you say, you're kind of recognizing in your experience something that others are maybe going to explain and
verify,
make sense of, verified.
Yeah, that you can verify that two people might have observed the same phenomenon, and therefore it's relatable, but also replicable. So that idea that you do an experiment to repeat something and check, oh, did it work? Okay, it works. That replicability that's involved in, I've had that experience, you've had that experience, is quite key and fundamental to scientific.
And it's also putting together something which is almost that convergence of experimental and experiential together. You know, that you're both an experiment, it's happening to you, but in your experience of it, you're understanding and it's revealing something. I wanted to come back to that combination of sensory information, but needing something more. Robert Grosseteste, writing theologian, scientist, writing in the late 1200s, talks about, for knowledge, we need sensory experience, but he says we get knowledge via the senses, but not from the senses. So that suggests, yes, it's got to be in there, but it's not going to deliver everything that will count as getting us to understand. So what else goes in there? What other parts are needed?
I think picking up from what Megan just said, and then even the previous time she spoke, I had the same impulse to talk a little bit about astronomy and astronomical observation, because I think it's just an excellent example to tie together this mathematical modeling, right, and then the experience of observation. And so there was a sense, and when you mentioned the communities of scholars who were referring to each other, this happens across time and space. And so people in medieval Europe are referring to Ptolemy, the ancient Greek thinker. They're referring to, not Al-Urdi, but right, some of the other Islamic astronomers who had been translated into Latin, and making observations and studying, okay, Ptolemy's models, his mathematical models, predict Jupiter should be here, right? And it's actually here, it's a little bit off, right? And so then every night making observations of planetary positions and matching them up to where Ptolemy predicts that they should be, and finding that discrepancy, and then being inspired again through reason to make better models, right? And Nasiruddin Tusi, as you mentioned, right, was heavily invested in this project of finding a corrective model that would bring together experience, but also reason, right? And what is the reason? Well, sometimes those are authoritative traditions, right? So there is sort of the Aristotelian tradition, which dominates this sort of worldview over the centuries. And so, okay, we must preserve this perfect spherical circular motion of the heavens. And so that's the reason, right? But then over time, even that ultimately falls, right? But it's the constant negotiation between our sensory experience, right? And then our own reasoning, and whether that reasoning should come from an authoritative tradition or from something else, right? Where this sort of, tension is, I guess, sort of always there within the history of science.
That's beautifully put, because I think that idea that we've got reason and modeling, which is sort of predicting something, but there's a correction to it when the observations tell us it's slightly off, let's go back, let's adjust. It's very close to something that's now terribly popular in contemporary neuroscience, the idea of predictive processing, which is we're sort of predicting what our experience will be like, and the experience is given to us through sensory input, either confirm or disconfirm. And if they confirm everything's good, just leave it alone. And but you learn through the disconfirmation, you learn from error messages, and it's as if through their observations, that's what improved their science. They were constantly revising. And we may hear a little bit more about the predictive model in the afternoon when we talk about the neuroscience of light and vision. I want to also come back to the idea again of practice, and the idea that when we're trying to get closer to how things are, we also have to find out whether the tools work. So there'll be, we see these beautiful astrolabes, but you can't believe that was the first shot, right? So there must have been tremendous amount of adjustment, refinement, attempts to get things right, and to use better tool making, better practice, ways in which we bring things back into that harmonious order that they were always seeking after.
I mean, I'm sure there was always that in the practice of any metal worker, any craftsperson, astrolabe maker. I think at the same time, what we see, this astrolabe itself, dates to the 17th century. There already was a very long tradition of astrolabe making, of course, but even in the medieval period, I mean, there were centers of metalworking production that were really respected centers. They were known for it. We have beautiful works that are made in some sort of copper alloy or brass with silver inlay, gold inlay, and so there's a familiarity already there. So once the instrument is understood, I don't think it was going to be very difficult to make it well. But you do see a difference. You start to see, I mean, in the Islamic world, why are astrolabes so important? Well, they're instruments of timekeeping, first and foremost, although they, as Taha Yassin Arslan has made very clear to me, they're like a form of computers, and we don't use all their applications and all the things they can do. You've talked about measuring, the distance of the height of buildings, or the distance between stars and us. they were a way also for Muslims to keep to their 5 prayers a day, to be able to know when to fast during Ramadan, to know the direction of prayer, and depending on which location they were at. And the plates in the middle of the objects, which you see over here, would be tied to whatever region that they needed to find this knowledge for. But there is a bit of you start to see a difference in styles. So where we have these pointers, I mean, we have these beautiful scrolling leaves, but their points will then also be the way that are star pointers. Whereas in some of the Arab lands, they might be simpler. And so it's more that the style changes because it becomes distinct to the region, and that's where the craftsperson could really start to have fun and play with the refinement of the craft as much as the function of the object.
I want to, before we open for questions, I want to sort of bring in the issue of beauty as well. So, we start with light, and most of the religious traditions will, of course, associate God with light, or, let there be light, and then Grosseteste thought that matter was the ultimate limit of light, turning into sort of physical form. But he also thought that light was connected to beauty, and that therefore the most beautiful thing in the heavenly sky was the biggest and most sort of luminous thing, the sun. And I'm wondering whether beauty is also one of those dimensions that has to be part of the complete story, has to be part of how they're telling the story. And when you talk about them having fun in sort of refining their delivery of these beautiful crafts, it is with that sort of aim at beauty. It is a sort of aesthetic urge, it seems.
I mean, it could be. And it's definitely a part of the experience, right? So, and I would say in Islam too, I would really heighten the sense of the oral and oral senses, because of the word, the importance of the written word, and that's how God revealed His word to the Prophet Muhammad. But then the way that's done, I guess it comes more toward the experience. And as we know, beauty can be defined in different ways by different perspectives. So I think when light does have that meaning, and it certainly does have a very important meaning in that sense, and with equating to God as well in Islam, the brilliance of the gold on the page, or the blue Quran, which is embellished, the words are written in gold, and the pauses between verses are in silver, or the luster technology, which is really the contribution that the Islamic world made to the rest of the world, that shining can also add and elevate the dimension. And I think in other crafts, it could be, or for Qazvini, is how the words are conveyed, how the words are spoken, how they sound. And his job was as much to entertain and bring solace to people as it was to give information. And that's where stories also come in as well.
Oh,
Megan.
Could I have the clicker?
Yes, of course.
So you might get car sick, but we're going back. Sorry. But it's just too perfect. So the line I didn't read from Augustine is, whatever delights you in a body and entices you in bodily senses is full of number. And so there is this idea that the frisson of aesthetic pleasure that we feel when we're looking at something that's beautiful, that it's touching the divine. It's realizing something that's divine and has a kind of perfection that we're designed to receive and recognize. And I think you're supposed to get that sort of frisson of aesthetic pleasure in looking at images like this, that this artist has created something as orderly, as perfected, in order to convey something of the perfection and order of the divine universe. And so I do think that idea that beauty is a tell, but I think it's a very broad, capacious category of beauty. Like, what is beautiful is basically what is all of divine creation. So I think it's not a narrow notion of beauty, but it's an actual
or
quite
what evokes
broad
wonder.
Yeah, and that's also that sensation almost of wonder is something that's telling you something, that you're getting closer to this divine knowledge, I think.
And it's an intellectual as well as a sensory experience to have that sense of wonder. And I also, yes, it's everywhere, but it's sort of particularly emphasized by brilliance, by the playing with light, by the having of mirrors which can reflect light in a space, by stained glass, by all of these methods by which light takes on a special significance for the person receiving it. So let me thank all of our speakers for their contributions, and now open it up to you for questions. A microphone will find you if you put up your hand. And I just remind you, a question is that thing that ends with a question mark. It's just handy to remember that sometimes. But while you're finding people, let me just read a question that's come in online. This is from Susanna Baxendal, who says, the marginalia of the Almagest reflects at least a superficial understanding of the use of the scientific instruments, with the triangulation on the illuminated capital actually shown. Is this unusual? Who would like to take that up?
I mean, I think that's my question.
Please.
So the marginal, can you ask it again?
Yes.
The marginalia reflects
the marginalia
what?
of the Almagest.
Yeah.
Reflects at least a superficial understanding of the use of scientific instruments, with the triangulation on the illuminated capital actually shown. So quite refined scientific understanding. Is this unusual?
Yeah. So I wouldn't call it marginalia. I think this is more designed. It's not someone who sort of was reading the Almagest and then made a doodle, right? Although those also exist and are wonderful. This was much more intentional, I think, on the part of the scribe and the illuminator, maybe. But there's certainly an understanding there. That's you can even see on, if I had a pointer, the quadrant. There is a little thing hanging down. It's really tiny. That's actually a lead weight that shows you that the quadrant is being held correctly. And so it should be hanging down perpendicularly to the ground, and then that's what allows you to then make that measurement. So there certainly is, I mean, these are fairly accurate representations of the instruments, and yeah, really playful caricature.
Thank you. Question here at the front.
Thank you. Yeah, I was thrilled with your phrase, predictive process disconfirmation. Well, I'm a middle school science teacher, and so I define science to my kids. And so Nadan took us to this thing that really struck me, and my question is, in the Shams al-Din Muhammad bin, where he speaks of science. I don't know if maybe bring it up on the board or whatever, but he uses the word science, and this is 800 years ago. And so I'm wondering what the etymology, because of course I don't know Persian or Arabic, but what the etymology of the word is. What did the word mean when he wrote it? And how does the language, where does that word come from him?
I actually feel, thank you for the question. I think it's an important question. We'll come back to the red. Is it going backwards, right? Yeah. I actually feel very ill-equipped to speak about Arabic or Persian etymology, because I'm sure that I would be corrected. My understanding of it, and in the way that I've sort of approached it, is that the word elm, and I know there are others here who can actually speak better to this than I can. It is the word for science. It's also the word for knowledge and knowing, and that encompasses more than, I think, what you would teach in school. You'd probably separate a science class from an art class, from a humanities class. But in a cosmography, which is sort of covering everything, all of these fields are covered, from astronomy to geography to mineralogy to the different skills and crafts, and even those are defined in a way that may not be the way we would define it now. And so I feel that the approach is that this is a sort of all-encompassing approach, to the world and discovery of the world. And there might be different types of knowledge, but that word, it's more overarching than I think it is when we think of science in English. And then I leave that, as I would never take my word as the final word on this, because I don't study etymology, but it is my understanding of that word. I even know. Can you give me the word again? Ilm, which is like this, maybe it's sort of a backward, like a little superscripted C, and then ILM. Ilm or olum, or in Persian it would just be elm.
You might also, yeah.
You could speak much better.
Yeah, I don't think much better, but
Like,
I can tell you one thing that's interesting is that there's a whole tradition in the Islamic world on the classification of the sciences, and so how the different sciences relate to each other. And so usually alam is used, so alam al-najum is the science of the stars, right? Sometimes they say alam al-falak, which is the science of orbs, right?
Yes.
And so there's different terminology that's used, but they're usually under that broader sub.
And then a differentiation maybe with sana, which is the craft, and so there is a distinction made as well. But
yes.
Thank you. There's a question up at the back.
Thank you so much for this delightful panel, as well as for the exhibits. I'm Marianne Horowitz from the History Department at Occidental College, where I've taught a course on Renaissance Florence. 15th century Florence saw the full translation of Plato into Latin and some into the vernacular. And I'm interested in the influence of optics on personal relations. And I particularly am interested in what impact this had on the Arabic-speaking world and in Persia. But in the case of Florence, women are encouraged to look down when they happen to be outside, and they're usually just outside for a, upper-class woman for some religious festival, and discouraged from looking at a man. Because of Plato's optics, there was the theory that there's an exchange of souls when a man and woman look at each other. Evidence of this you could see at the very end of Castiglione's book of the Courtier, which is in English, and Leo the Hebrew's philosophy book, also in the relationship between the scientist and the woman whom he's having a dialogue with. This topic comes up, and I'm simply wondering if in Persia or in Arabic-speaking worlds, this Platonic, this what is now out of date in the West, from the 17th century on, Aristotle's theory of optics then became dominant, whether a lingering of Plato's theory of optics discouraged relations, male and females looking at each other for the risk of exchange of souls that's discussed at the end of Castiglione.
Good, thank you.
I don't think the Timaeus, and I could be wrong about this, it wasn't translated with the other Greek translations that happened in 8th and 9th century. And if it was translated, it certainly was not as popular as the other optical works. And so I've never heard of that.
I haven't either.
Megan?
Oh, yeah, go ahead.
No, the Timaeus was the only work of Plato that was translated earlier. It was all the rest of Plato's works that's not translated until the Renaissance period. But they did have the full optical theory in Latin. I'm not sure. What I would say is that even in Augustine, you get the idea that looking affects oneself, and so one has to be very careful. And I'm not sure if that basic understanding that.
Look.
Oh yeah.
So Nadan has an evil eye bracelet, and I was waiting for you to remember.
I did not think about that.
Yeah.
I mean, there's got to be something, I guess. There is a tradition of warding off the evil eye, warding off. But I've never tried to go back to the source of that. I just believe that if I don't wear this, I'll be in trouble. So.
Okay, no, we've got some other questions. Let me spread it out. We got another question at the back, but I'll take one online before we hear from you, if I may. This is from Deborah Oropeza, who says, did Christian society in Europe openly or without question accept Arabic scientific traditions despite their non-Christian origin?
That's such an excellent question. Thank you for asking that. So that's an area where I've done a lot of research, and what I found fascinating is that early in the 11th century, 12th century, the earliest astrolabes were found in Spain and that area. And so Latin scholars, right, were really excited about this new technology. And there are records, for example, of Adelard of Bath saying, let's all go to Spain, right? There's a wealth of knowledge there that we would love to recover from the Islamic world. And then, of course, the Arabic Latin translations began, and then there was this enormous influx of Greek and Arabic knowledge coming into Europe during that time, and there were generally there's a lot of enthusiasm about it in the beginning. Over time, you began to see different critiques of knowledge coming from the Arabs. Sometimes they were called superstitious or barbarous, right, is another word that's used. And so those were sort of small pockets. That said, particularly in the area of astrology and astronomy, they've done manuscript studies to show that the number of manuscripts that were translated from Arabic actually outnumber Latin manuscripts on astrology in medieval Europe. And so in the field of astrology, there were more Arabic manuscripts. They were, of course, translated into Latin, but they had Arabic origin authors, and these were all taught at universities and widely spread. Some of them were translated in court settings. Some of them were commissioned to be translated in different court settings. And so there was a lot of enthusiasm that persisted for centuries. Despite this sort of also anti-Muslim sentiment that also came up from time to time in different areas and settings. And so it wasn't really until the humanist movement when a distinguished professor also mentioned, right, this recovery of original Greek sources, that then there was more criticism of the Arabic tradition because the Latin translations from the Arabic were just kind of messy, right? And they were more difficult to read. And so then there were sort of more criticisms, and eventually, right, there was this sort of fall from grace, I would say, within the European scientific tradition for the Arabic tradition, yeah.
Was it also true, though, that when the Latin translations from the Arabic of the classical texts was going on, that was also giving Latin scholars access to original Arabic texts beyond the...
Yes, absolutely. Yeah. So that's what I was saying about the astrologers. Right. Al-Khabisi, who I've worked on, right, was the main introduction. He wrote the main introduction to astrology, taught at universities all over Europe,
so
right?
This is the way it got in, despite some reservations,
There were no reservations in
not about the science, but about the, we want to translate these works. We'll have to look at these Arabic translations. Oh, but now we're learning all this fascinating stuff because it gives us access to the other Arabic texts. So in a way, the translation story is quite important for the transmission of Arabic science into the Christian tradition.
I would say that there's also, I'd have to say that there's just this constant cross-cultural transmission that's happening, and I think India is actually a fantastic example of where you have, we have a star map or a star chart in our exhibition that is showing the superimposition of the 27 lunar mansions in Indic astrology over the Ptolemaic, the Greek Islamic constellations, and that this is the type of map. There's actually a print by Dürer where he has these different philosophers on each corner. Some of you may know, in one corner is Al-Sufi. So that there's that awareness because there's this convergence of these different perspectives and these different, paths of knowledge that are all converging, and they coexisted, and they were aware of them.
Yeah, this is the point you originally made about the common knowledge of science despite different religious settings for it, which I think is important. We've got time to squeeze in one last question. I think there was somebody with a microphone at the back. Quick question, quick answer, please.
Okay, I was confused about the use of the word number.
Could you hold the microphone here? Thank you.
I was confused about the use of the word number in your first image, is that a description of the medieval universe, which is Earth-centered, or were they equations, or does it mean quantity? What would they mean by number?
Yeah, so number as in its geometric form. I wanted to use a Getty image. And this is a very ordered image of the universe that looks like other cosmological images that are circulating at the time, like they're taking their cues from diagrams of the universe that are setting out understandings of the balance of the elements, the place, the sort of configuration of the world in circular diagrams. And this diagram that stands in a missal, so a liturgical book that was used in Christian devotional practice, creates creation in this same orderly fashion, lightly referencing or hearkening to a kind of diagram that was quite typical in cosmological, in works on astronomy, for instance, or just on the nature of the world, et cetera. And so when I say that it was representing number, it's representing the world in this highly ordered geometrical fashion where you had to use a compass, you had to use a straight edge, so it's via circles and lines, these essential geometric forms, and number underlies those forms. And so number is used as sort of the broad category, and it's studied through geometry, arithmetic, music, and astronomy. And so to manifest it, you would use geometry to show the world. Because again, geo is terra, is earth. Metry comes from to measure, and so the idea that one measures the earth, that there's a strong link between representation of the world and that particular form of mathematics was very close. Is that clear? Was that what your question was? No.
It'll have to do. Before we thank our speakers, let me just remind you that we'll be returning, for those of you who can, to have our second session of the day, and we'll start at 2 o'clock, and we'll discuss the neuroscience of light. I'd like to thank all of you. I'd like to thank those of you who joined us online, and then now I'd like to invite all of you to thank our speakers, Megan McNamee, Margaret Gaida, and Ladan Akbardia. Thank you very much.